Okay, so in this video we're going to convert a binary float to decimal using single precision format. Okay, so the question will have a very large binary number, something similar to this that we've got in front now. That's nothing to be intimidated by. The process is very simple. So if we start with this furthest left bit, this number here, or this digit here, represents whether the answer is going to be positive or negative. So if it's a 0, it's going to be positive, and if it was a 1, it's going to be a negative answer. So we'll save that down here for now. So we're going to have a positive answer in this instance. The next step is to take the next 8 bits, so 1, 2, 3, 4, 5, 6, 7, 8, and draw a line. We'll separate them. Okay, so we're going to want to convert this to decimal now. So it'll be 128 plus 4 plus 2 plus 1, which gives us 135. And then we want to subtract that, or subtract 127 from 135, which gives us 8. So 8 is our exponent. So if we just write exponent equals 8, and then we can move on to the next bit. Okay, so the rest of our answer is going to come from this huge number here. But if there's zeros after the ones, then we don't need to worry about it. So this is a relatively simple answer. However, if it was 101, we would need to think about it a bit more detail, or 1001. But for now, because all of these are zeros, and I'll show you why that's going to be. So this is our mantissa. And effectively what we want to do here is all the digits that have got a 1, or the binary digits that are a 1, we want to multiply that by 2 to the power of the number that it's in reference to. So for example, 1 times 2 to the power of minus 1 is this digit here. And I want to add 1 times 2 to the power of minus 2, because this is the second one. And then we would add 0 times 2 to the power of minus 3, add 0 times 2 to the power of minus 4. Those are coming from these zeros here, the places in the mantissa. So obviously it's going to give a 0 answer, so we don't need to worry about that. So if we just go onto our calculator now, and let's see, so we can see it. So we want 1, 2 to the power of minus 1 plus 1 times 2 to the power of minus 2. That's going to give us our answer of 0.75. So if we go back to this example here, this equals 0.75. Okay, so now we need to bring this all together. So our first bit signifies it whether it's a positive number. Our next bit is, or our next bit of the formula is 1 plus our mantissa, so it's plus 0.75. Gives us 1.75, and then I want to times that by 2 to the power of our exponent. So our exponent was 8, that's where that's come from. Okay, which gives us an answer of, let's get our calculator back out. So let's clear that, and it's 1.75 times 2 to the power of 8 equals 448, and that is our answer. So our answer equals 448. Okay, and that is a relatively simple example of converting binary float to decimal using single precision float decimal